In the previous video, we've had a look at what valency means, and let us just quickly continue the discussion further and move on to another small concept here. So let's take the example of sodium again. It is a simple example. I have 11 protons, 12 neutrons, and I have 2 electrons in the first shell and 8 in the next second shell. 1 2 3 4 5 6 7 8 and 1 lonely electron in its outermost third shell. Now, to achieve its stable configuration, sodium decides to get rid of this one electron. So it just leaves this electron, and now it has lost this electron. Now, where does the electron go and what all happens? Who takes this electron away and how this actually happens? We'll come to that in the next video, but here let's just look at what happens if the sodium somehow loses this electron. Now, if you look at this, let's just keep it even further ahead in this very corner. Yeah, it's out of our sight now. Now, in this atom I have 11 protons, and it will have to have 11 protons for it to be sodium, because if we change the number of protons, we will be changing the atom itself, the element itself. And it's left with only 1 2 3 4 5 1 2 3 4 5 6 7 8 9 10 electrons and electrons. And if we look closely, it has an extra proton here. It has 1 proton more than 1 electron. So if we find the net charge would be 11. The 11e. So plus 11e plus shows that it is the charge of protons, and we have 11 protons. E is simply the charge on 1 proton. Minus shows the negative charge of electrons, and we have only 10 electrons, and E again shows the charge on 1 electron, and the net comes out to be plus 1e. Now we tend to just remove or ignore this E for now, and I'll just say that this has a positive 1 charge or a net charge of plus 1. I'll just remove the mathematical part here, and so the net charge on this atom is plus 1. And how do I write that? Well, I can simply write this as, write the symbol here. This is sodium Na, and I can just write a plus 1 there. And sometimes we just tend to just remove the 1 there, and you can only write a plus sign there, which just simply says, so even if I write it as this Na plus, it simply means that it is Na plus 1. We just sometimes tend to not write that 1, but if there's a 2, we write the 2 there. We don't skip the 2. But yeah, for now we'll stick to this. We'll write Na plus 1, and if somebody just writes this somewhere, you can know that he simply means to indicate that there's a sodium atom Na, but it has lost an electron, and it is now it just has 1 extra positive charge due to that extra proton, and that is why this thing has a plus 1 charge. So now this is charged, it has a net positive charge, and yeah, now such charged atoms, in this case it is positively charged, but we can also have negatively charged atoms. Similarly, so if let's say some atom gains some number of electrons, it'll have some extra number of electrons, and those extra number of electrons will give it some extra net negative charge, and so that atom will become charged. Now, just like this atom, if we can have other charged atoms, and such charged atoms are called ions. IONS, ions. And yeah, that's it. That is what an ion is. It is simply an atom that has either lost or gained some electrons, and by losing or gaining those electrons, the number of electrons and protons are no longer equal, so the atom has a net either positive or negative charge, and yeah, that just makes that atom an ion. Now we can have positively charged ions like sodium ions, and we can have negatively charged ions, for example chlorine and other such examples. But yeah, we can have ions of both the signs, both the types of charges, and yeah, that is what an ion is. That's it for this video.